Okay guys, this week you'll be doing your first real experiment where you're making measurements. The experiment for this week is called Density of Liquids and Solids. Horrible title. Okay, we do have you measure the density of all kinds of different things, so you'll be making measurements of density. But what this experiment's really about, it's really about you applying the rules of significant figures in your calculations. I think this experiment should be titled Application of the Sig Fig Rules. So what I'm going to do in this video is give you a quick review of significant figures. And in a later video, I'll walk you through the experiment and how to complete the lab report. But for right now, let's look at sig figs. Now, when most people take science classes early on, this topic drives them batty, the significant figure thing. And there's a reason it drives them crazy. Your whole life you've been taking math classes. In any math class, 5.000, they're the same darn thing. Those two numbers are the same. My calculator, it's not a science thing, it's just a math thing. The calculator understands math. And to this calculator, that is absolutely 100% the same as that. So in math, these two values are identical. But guess what? You're not in a math class anymore. You're in a science class. And in the sciences, we don't just have numbers. We have numbers with units on them because everything's based around measurement. We make measurements of things. For instance, you might be asked to weigh this thing, figure out what's the mass of this marker. If two different people make the measurement and one of them reports 5.000 grams and the other reports, oh yeah, we weighed it and it's 5 grams. Well, to a scientist, this does not mean the same thing as this. It's a measurement. Here's the deal. We know there's always some error in any measurement. The way we express how certain we are of the measurement, how much error is in the measurement, is we assume there's an error of plus or minus 1 in the last place. So here's our places. This is the ones place, the tenths, the hundredths, the thousandths place. So if somebody says, yeah, we weighed it and we got 5.000 grams, that's telling me, oh yeah, an error of plus or minus 1/1000th of a gram. So they're saying, yeah, we weighed it. It might be as light as 4.999 grams. It might actually be as heavy as 5.001 grams. So this is telling a scientist that that marker weighs somewhere in this range. Now, look at this value. Somebody weighs it, says, yeah, it weighs 5 grams. Again, I have to assume an error of plus or minus 1 in the last place. Well, the last place happens to be the ones place, right? So 5 grams means, oh, it might be as light as 4 grams. It might be as heavy as 6, an error of plus or minus 1. Hey, this is not the same as this, is it? And that bugs people. Like I said, your whole life you've been told this is the same as this. And that's true in math. However, in the sciences, we're dealing with measurements. And for a measurement, this does not mean the same thing as this. The more sig figs you have, the more accurate you're implying that your measurement is. So, what we're going to do here, 3 parts of sig figs. First, we're going to go through how do you read an instrument properly? When you're the person making the measurement, you have to figure out, do I record the measurement to 1 decimal place, 2 decimal places, 3 decimal places? So let's go into that. If you look at page 17 of your lab manual, it has these pictures here of a couple of rulers. These are centimeter rulers. And anytime you have to make a measurement with something like this, you look at the thing and you figure out what's the way it's marked. What place is it marked in? Oh, this one's marked in the ones place, right? This is 1 centimeter, 2 centimeters, 3 centimeters, etc. How about the upper ruler? The upper ruler is really marked in the tenths. This is 1 centimeter, but that 1 centimeter has been subdivided 10 times. So each little line is 1/10. So this one is marked in the ones place. This one is marked in the tenths place. Now, you always figure out how it's marked. If you're marked in the ones place, do you read it to the 1? No, that would be crazy. Nobody would look at this measurement right here and call this 2. You'd probably call it 2.3 centimeters. Somebody might disagree and say, well, I think it's 2.2 centimeters. Somebody else might say, it's 2.4. That last digit there is the so-called estimated digit. Some people call it the uncertain digit. And sometimes people will go, well, why do we bother recording an uncertain measurement, an uncertain digit? Oh, because any one of these measurements here is better than calling it 2 centimeters. Again, it's marked in the ones place. If you record it to the ones place, it looks stupid. Don't do that. If you're marked in the ones place, you read it to the nearest 1/10. Okay, the upper ruler, you're marked in the tenths place. Don't read it to the tenths place, read it to the hundredths. So you're looking at this measurement, this would be 2, 2.1, 2.2, 2.3, 2.3 something. You probably want to call it 2.34 centimeters. Again, somebody might disagree, call it 2.33 or 2.35. But any of these is better than calling it 2.3. We know it's not 2.3. We know it's a little bit larger than 2.3. So, reading an instrument, you have to figure out, is the thing marked in the ones place? If it's marked in the ones, you read it to the nearest 10th. If it's marked in the tenths, you read it to the nearest 100th. If it were marked in the hundredths, you would read it to the nearest 1,000th. If you want some practice doing this, we have a ruler down at the bottom here, page 17. You can see if you can read these and come up with these values. Next topic in significant figures is counting significant digits. So, counting significant digits is probably the easiest thing in this whole area. They probably told you in the lecture, if something's not a 0, it's counted as significant. The difficult thing is zeros. Sometimes you count zeros, sometimes you don't. So you have to develop a skill where you can look at numbers like this and say, oh yeah, this represents 5 sig figs. This value here represents 3 sig figs. This value is 4. This one is 6. This is one lousy little sig fig here. This is 4 sig figs. Now, if you're wondering how I did that so fast, the rule for counting sig figs, and this applies to anything with a decimal point in it, is you read your number from left to right. You probably already read that way. As soon as you see something that is not a zero, you start counting. So as soon as you see something that's not a zero, start counting. Once you start to count, don't stop. So I'm reading along. Hey, he's not a zero. I better count. 1, 2, 3, 4, 5. This value represents 5 significant figures. Next example. I'm reading along. Hey, he's not a zero. I start counting. This is 1, 2, 3. This measurement represents 3 significant figures. Here, start my count here. I've got 1, 2, 3, 4. Once you start to count, don't stop. So that represents 4 sig figs. This guy would be 6. Here, you're cruising along, all these zeros. Haven't hit a non-zero yet. Oh, he's not a zero. I start counting. That's 1 significant figure. This measurement represents 1 sig fig. This guy would be 4. Now, occasionally you get numbers with so-called trailing zeros in them and no decimal point. They're ambiguous. This might represent 1 sig fig. It might represent 4. We're never going to ask you that. We're never going to give you something like this and say, how many sig figs? That would be asking you to read our minds. However, you should be able to take a number like this and write it to the correct number of sig figs. If we say it's 2 sig figs, then you'd have to say 2.0 times 10 to the 3rd meters. Here's the lesson. When things are expressed in scientific notation, the significant part is that part, the part before the multiplier. So this represents 2 significant figures, but it also, because of this 10 to the 3rd, it represents this number. So yeah, this represents 2,000. But it's only accurate to 2 sig figs. In other words, if you rewrote it, the 2 sig figs would be, take us to right there. Oh, it's 2,000 plus or minus 100, because that's my 2 sig figs. So it's 2,000, give or take 100, because this is the hundreds place. So again, in scientific notation, which part gets counted as significant? The part before the times 10. Next topic here is when you're doing calculations. We have one set of rules for how to handle sig figs when you multiply and divide. Then we're going to have a slightly different rule for handling sig figs when you add and subtract. Multiplication and division is real easy. When you're multiplying and dividing, you look at each term and you count how many sig figs are in each term. So if I had to do this, 6.19 times 2.807, this term here, that term is worth 4 sig figs. 6.19, that is worth 3 sig figs. So when I multiply them together, I can only keep 3 sig figs in the answer. Whichever term has the fewest sig figs, that determines how many sig figs I can keep. So if I do this on my calculator here, if I do my 6.19 times 2.807, my calculator is going to spit out all this. How many sig figs do I get to keep? 3. So I keep the 1, the 7, the next digit. Hey, do you see how this 4th digit is higher than 5? So I'm going to round this up to 17.4. So I would have to call the answer here 17.4 square centimeters. So again, because of that, I only get to keep 3 figures in my answer. So I read along, first 3 figures. That last one I'm keeping, we look over, and if that next digit is 5 or higher, we round this up. If this, instead of a 7, if this were a 2, I would have called it 17.3. So that's how that works. Now, in this one, I got 1, 2, 3, I have 5 significant figures on the top. I only have 2 on the bottom. So when I run it through my calculator, I only get to keep 2 digits. So we have 9.6245, 9.6245, 9.6245 divide by 2, and I get to keep 2 figures. I'm going to call that 4.8. I don't round up because you notice the next number over is less than 5, so it's going to be 4.8 grams per milliliter. Now, this next one's interesting. Looking at it, let's see, I only have 3 significant figures here, so I'll only be able to keep 3 figures in the answer. Now, evaluating this one, this has nothing to do with sig figs, has to do with calculator usage. What you want to do is 4.01 multiply it by 3.250, then you're going to divide by 1.500, and then you're going to divide by 7.5660. I know some of you just freaked out and said, no, you multiply. No, you're going to divide. If a number's on the bottom, you do division. Here's a quick example. Let's give you a real easy problem that you can do in your head. Okay. 5 times 10 over 2 times 2.5. You know the answer to this. 5 times 10 is 50. 2 times 2.5 is 5. So the correct answer is clearly 10. That's the correct answer. You know this. Now, how would you put it in your calculator? You got 2 choices. If you said 5 times 10 divide by 2 times 2.5, 5 times 10 divide by 2 times 2.5, guess what you're going to get? The wrong answer. So don't do it that way. I'll show you it's the wrong answer. Let's do it. If you do 5 times 10 divide by 2 times 2.5, you end up getting 62.5. Lesson to be learned, don't do it the wrong way. Do it the right way. If a number lives on the bottom, that number has to get divided into the top. So you can do it as 5 times 10 divide by 2 divide by 2.5. Watch this. 5 times 10 divide by 2 divide by 2.5. Oh, hey, we get the right answer. So again, when you see setups like this, and you're going to see a lot of setups like this in the sciences, things on the bottom, divide by them, and you end up getting the right answer. So anyway, if you did this one, again, you get to keep 3 sig figs, so your answer is going to end up being 1.15. 3 sig figs. Let's take a look at addition and subtraction. Addition and subtraction, we have a similar rule, but here's the deal. When you're adding and subtracting, you're not really even concerned with significant figures. You're concerned with decimal places. They're not the same thing. Take a look. If I had something like 32.050, how many sig figs is this? 1, 2, 3, 4, 5. Oh, this represents 5 sig figs. How many decimal places is this? Well, there's my decimal point. It's 3 decimal places. So, significant figures, decimal places, they're not the same thing. And when you're adding and subtracting, all you're worried about is decimal places. Examples on the next page for you here. If you had all these things thrown into a beaker together and you had to add them up, so you have this many grams of water, this many grams of sodium chloride, this many grams of sugar, which is sucrose. If you add them all up on your calculator, 25.5 plus 0.005 plus 1.23, you end up with 26.735. But the rules say you got to look at your decimal places. 1 decimal place here, 3 decimal places, 2 decimal. Hey, since you only have 1 decimal place here, you can only keep 1 decimal place in your final answer. So you'd have to call this thing 26.7 grams. This part's extraneous, worthless. So again, when you're adding and subtracting, what you're worried about is how many decimal places are in each term. Whoever has the fewest decimal places, that's how many decimal places you keep in your final answer. I hope this helps out a little bit with the sig fig topic. It takes some getting used to. Next video I should have up for you will walk you through the density report sheet and how to fill that out. Take care.